So, what is a capacitor? A capacitor consists of two conductive plates separated by a dielectric material. This dielectric could be air, ceramic, or a polymer film. It's a little bit like a battery, except it stores energy in a different way. It can't store as much energy as a battery, although it can be charged and release its energy much faster. This unique property makes them very suitable for applications that require quick burst of energy, such as flash of a camera, starting a motor, and smoothing out variations in the output of a power supply. When you connect a capacitor to a power source, let's say battery, electrical charges build up on those conductive plates, with positive charges gathering on one side and negative charges on the other. This separation of charges creates an electric field, which stores energy. Think of it like a water tank. You're storing water in the tank through the discharge of a tap. The water in the tank can be used later when the tap is off. Just like the tank, the charged capacitor can be used to power a light bulb when charged. The amount of charge a capacitor can store is measured in farads, named after Michael Faraday, and the capacity of a capacitor to store charge is called capacitance. Most capacitors deal with tiny amounts of charge, like microfarads or even picofarads. Capacitors are all about those quick bursts of energy, making them perfect for things like smoothing out voltage fluctuations or blocking AC current while letting DC current pass through. Now that we got the basics down, let's meet the capacitor crew. Just like there are different types of batteries for different jobs, there's a whole different types of capacitors out there. First up, we've got the ceramic capacitors. A ceramic capacitor is a fixed-value capacitor where the ceramic material acts as the dielectric. It is constructed of two or more alternating layers of ceramic and a metal layer acting as the electrodes. The composition of the ceramic material defines the electrical behavior and therefore applications. They are mostly very small in size. They're often used in high-frequency applications like filtering out noise in circuits. Next, we have the electrolytic capacitors. These are a polarized capacitor whose anode or positive plate is made of a metal that forms an insulating oxide layer through anodization. They are capable of storing much more charge than ceramic capacitors. Electrolytic capacitors are often used in power supplies to smooth out voltage ripples. But here's the thing about electrolytic: they have a positive and negative terminal, kind of like a battery. So, you gotta make sure you connect them the right way around, or else they explode. Next is tantalum capacitors. They are a bit more compact but still capable of handling a decent amount of charge. They are extensively used in electronic devices that require stable capacitance, low leakage current, and where reliability is crucial. You'll often find them in mobile phones and laptops. Lastly, we have the film capacitors. These are the audiophiles of the capacitor world, known for their low noise and high accuracy. They're often used in audio equipment and other high-end applications where signal quality is critical.